Okay, let's continue our discussion. So today we are going to start a new topic, gravitation. Let me give you brief history about it and then we will come to this part, Kepler's laws of planetary motion. So what was happening earlier? People started observing that there is a force of attraction exerted by the earth on the bodies near it. So they started observing that whether it is a raindrop or it is a ball thrown near the ground, all these bodies are coming back to the surface. So there must be a force of attraction due to these bodies are coming back. And later on, Galileo, by his experiments, found out that this force of attraction is producing a constant acceleration irrespective of the mass of the bodies. So whether it is a heavy body or a light body, so all these bodies are experiencing this force of attraction, gravitational pull, we can say, and the acceleration due to this gravitational pull was constant irrespective of their mass. Then people started proposing models how these bodies, even moon. Later observation found out that moon is also revolving around the earth. Maybe it is also the cause. So people started making models. So we know a model was proposed, geocentric model proposed by Ptolemy. So what he said that the earth is the center and every other celestial body are revolving around this earth. This model was known as geocentric model. Further, another model was given by an astronomer and mathematician Aryabhat, and he said that earth is not the center actually, rather the sun is the center and the earth is revolving around the sun and many more planets, all these planets which we know. So other planets are also revolving around the sun and sun is at the center. So this model was known as heliocentric model. And the same model was further proposed by Nicholas Copernicus, and he also said the same thing that the sun is at the center and other planets are revolving around the sun. But unfortunately, he faced prosecution because his model was against the belief of the state. Later on, Tycho Brahe, he started observing the motion of planets, and there was no telescope at that time, so he started observing with naked eyes. So he observed, he collected data, and based on those things, his pupil, Johannes Kepler, he studied and then he proposed three laws of planetary motion. What we are going to discuss now. Okay, so let's start the first law here. So the first law, which we also known as law of orbits, law of orbits. And what he said that the planets are revolving around the sun in a fixed elliptical path, and the sun is placed at one of the two foci. So let's say a planet is here revolving around the sun on elliptical path. Let's say here we have planet something p prime, and we know the ellipse has two foci. So one of these two foci, let's say at this point, the sun is present. So you can state the law of orbits that all the planets revolve around the sun in elliptical orbits, and the sun is situated at one of the two foci. So here focus 1 and here focus 2. Okay, let me a little bit describe about ellipse. An ellipse is a geometrical figure here. Okay, let me draw here coordinate axis. This is z axis and this is, let's say, y axis. So this is an ellipse. Okay, and this length, this bigger length, let me write some notations here. Here, O, this is, let's say, P, and this is, let's say, A. And if we are considering this ellipse, so we can consider two foci here, and at one focus there is sun. And let's say here we have this planet P prime. Okay, so what happens in this elliptical path? These planets revolve around the sun, and for this ellipse, this length, let's say PA, from here to here, PA is, let's say, 2A equals to, we are denoting this length 2A. This length is called, or this from here to here, length is called major axis of the ellipse. And then there is another such length which is shorter than this. Let's say this point is something M and this point is N. So let's say MN is, this length is 2B here, from here to here. This length is 2B. So we call this axis minor axis. And why is it minor axis? Because it is shorter and this axis is longer, which is major axis. So PA is here greater than MN. And by definition, we can say this as ellipse if it follows certain things. So one of the most important thing is, if we do this length F1 P prime and F2 P prime, so the sum of these two lengths F1 P prime plus F2 P prime is a constant, and this constant is equal to the length of major axis. This is basic thing for an ellipse. So if there is a geometric figure, these 2 points are there, and if the sum of these two lengths is always constant for each and every point on this geometrical figure, then we say this is an ellipse. Okay, and we have equation for this ellipse. Let's say at this point O, which is here at center or origin, let's say this point is y naught z naught. So equation we have y minus y naught square divided by a square plus z minus z naught square divided by b square equals to 1. In this scenario, this is the equation for this ellipse. Okay, let me make it more familiar. What you might have studied. In general, you have studied if this is y-axis and this is x-axis and this is ellipse and this is, let's say, origin 0 0. So you might have studied that this length O2A and this length O2M, this length is half of the length of minor axis, which we call semi minor axis. So B is semi minor axis and A is semi major axis. Okay. So in general, you might have studied that x square divided by a square plus y square divided by b square equals to 1. And if you take a special case where a square equals to b square equals to r square, then it will become a circle, means equation of a circle. Here, this will become x square by r square plus y square by r square equals to 1, or you can say x square plus y square equals to r square. So this is the equation of a circle which is of radius r and its center is at origin. So this is the circle.